Ladies and gentlemen, welcome everyone. I am Dr. Roland A. Drolet, PhD in Biomedical Engineering from the University of Toronto, 1971. I am the developer and inventor of the Rumart Bihm system that has helped over 1 million people all over the world who were suffering from all kinds of health problems. So let me just start with this general equation of relativity. Title is in French, but the equation of Einstein, it's almost the same. General relativity, you have here what is called the tensor of energy tensor, okay, which is function of the mass and energy in the universe that is actually present and doesn't change much. Here you have the what is called the Einstein UV parameter, which is related to the geometry of the universe. Okay, so you have here the constant which vary each point of the universe as a function really of the mass that are present in the surrounding. Okay, so actually, without going into all the details, we could say that this equation shows a relation between the energy and the mass in the universe, if you will, that determines the curvature of the universe. Because when you have very large mass, then the space is like a curve or deform, and this is the genius of Einstein, who has realized that actually in order to have equation that will actually remain true when there are large mass, he made the relation between the gravity and the acceleration, and he realized that really the movement of mass here will be determined by the presence of mass and energy that will curve the fabric of the universe, the space, if you will. Okay, so this is how space becomes a function of time and time a function of space. So we don't talk about just space or time, but we can talk about space-time, okay? And here in this equation, when the number 1/2 is changed to 1/4, okay, then it relates to what has been called the best equation, Einstein equation, when electromagnetic energy is present in the universe. Okay, so I won't go into much detail there, except saying that when here you have an initial I would say what Einstein I call the cosmologic time constant, or not time constant, but the cosmologic constant simply. This is related to the Hubble constant. Actually, the Hubble constant is the Einstein cosmologic constant divided by 3, okay? Probably because of the 3 direction. So anyway, I'm just going to tell you a little bit about Einstein's equation for a particle. This is Einstein's equation, well known, mc squared. Here he used energy. In some of my presentation I used W for the energy that comes from work, because I've used E for electric field. But here E is Einstein's energy in the system of center of mass, mc squared. But if you take the energy of the particle square, according to Einstein in experimental measurement, you have what is called, what would be the square of the energy in the center of mass system, okay, because it is square, but it is separated or independent of the energy of impulse. So Cp, this is the impulse and the speed of light. In other words, on top of the energy of mass, mc squared, you have an energy of impulse because a mass is moving, for instance, and in terms of particle, the momentum P has been defined by Bohm, David Bohm, as not only the mass by the speed, but plus a factor involving the electric charge of a particle and what is the potential vector in magnetism from which the magnetic field is deducted. So it's not important to know all the details about that now, but just remember that momentum in quantum mechanics is not only mass multiplied by speed, but it has a factor perpendicular to the speed when the charge, the electric charge is breaks when it hits another charge. It induces in the air a potential vector or magnetic field, if you want, perpendicular to the motion there. And that is what is going to create actually electromagnetic photon from mass. So a part of the mass would be converted into energy of photons. In terms of electrons, if it moves fast enough, it will give two opposing gamma rays, as we will see in the next page of presentation. And on top of that, I would add the Dirac equation, where he has taken A and B as the multiplier of impulse and B multiplier of the mass as the energy. So if you place the square of this energy with the equation of Dirac, you end up with an equation which will be different from that. So I have equated this equation to this one squared, as you will see in the next sheet, and then I realized that it automatically gives birth to electromagnetic wave from mass if you only choose the A factor here much smaller than the speed of light and B much smaller than c squared. Why c squared? Because this factor is the energy of mass and the units of B is like square of a speed, because you have here mc squared. But here P as the unit of mass times speeds. Okay, so this is why it is only C there. So AB, product AB will be much smaller than C cubed, and when two particles hit each other, if they have enough energy, they can create any type of smaller particle. So now, following the presentation on the page 12, we get to page 7. This is really, it looks like a big mess, this page, I admit. But forgive me, this is why I've shown you page 12 before, and you will recognize the equation I've shown you more clearly in page 12. The square of the energy, this is Einstein's equation, you recognize, and this is Dirac's equation, the name I've written there. Bohm's equation, I've talked about a little bit. And this is Rodrol's equation that I didn't show you, but I told you that if you square this with simply high school mathematics, you get this parameters, 3 times parameter, and which are different from the Einstein's equation, which Einstein's equation holds only the first and second p squared c4, but here you have in Bohm's equation squared, you have these parameters p squared and pm and m2. I just realized that when you equate this equation with the parameter a and b introduced by Dirac, you equate this to this, which has the speed of light in both factors instead of a and b. When you equate this to this equation, what you end up after some calculation, here I said Einstein's equation equal Rodrol's equation, that means Einstein's equation, Rodrol's equation, this one. Then when you solve the quadratic equation for mass, you end up by, when you divide by the mass each factor, you end up, if you are a bit smart in high school mathematics, you will end up with something like the mass is equal to momentum multiplied by a messy factor here, I would call. But when you use the fact that A will be much smaller than C squared, and B much smaller, A much smaller than C and B much smaller than C squared, you'll end up that this is much smaller than that. So this will be the dominating factor. Just roughly, you will end up that the velocity of the particle before hitting the other particle, okay, is given, the afterwards velocity is given by the previous velocity plus or minus a perpendicular factor, which actually is the energy of the photons emitted perpendicularly to the motion of the particle. So here you have a little drawing where you have, example, the elimination of what we call positronium, positive and negative electron circulating against one another, which will give two gamma photon if they have enough energy. So when they hit together, they will annihilate and produce two perpendicularly emit photons. But if you have two perpendicular photon that would hit together, it would cause a reversible phenomenon. So this is well explained in the book Nuclei and Particles from Emilio Segre, an Italian physicist, and this is quite a complicated book of nuclear physics and particles, but this is just to show you that this is not just theory, this is experimentally verified, and from this simple equation there, you end up realizing how Feynman discovered what he called today for the last 25 years Feynman diagrams. He won a Nobel Prize for that. But here, with simple mathematics and a little bit of knowledge about complex number, we realize that with simple equation we can realize that from electromagnetic energy you can create matter and antimatter, and reversely. So I'm going to conclude here because I don't want to get more complicated than that. But this applies to all kinds of elementary particles, and I would conclude on the fact that even the predominance of matter over antimatter in our universe cannot be explained if we try to understand with only our universe. So in order to make this coherent with Einstein and general relativity and quantum mechanics, we have to admit that there are other universes that are predominantly antimatter. So, and these other universes, according to Buddhism and to what we call Théorie des cordes in France, or rope, or wavelength theory, multidimensional theory in physics, we have realized that there could be an infinity of universes. But this is enough for this presentation. I hope, if you are interested, that you see the reference that are mentioned there. So take care. I'm pleased to have you that far, and the next one are going to be simpler. Okay, so stay with me, have a good day, and keep smiling.